Optimization is the process of finding maximum or minimum value of a function, and the solution is often called the optimal solution. But what is the maximum and minimum value of the function above? It's a good idea to revise maximum, minimum, global or local values. What exactly does it mean? If you look at this particular function, you realize that there are turning points in it. In fact, there's 3 turning points there. We could look at A, B is a minimum turning point, and C is a maximum turning point. And you know that they are turning points, so I'll just put TP for turning point, TP in each case for a turning point. And A is a maximum, B is a minimum, and C is a maximum again. And there are also 2 endpoints, one endpoint D and another endpoint E with a value. So we've identified 5 points. Now, if you think of the word global, what does it actually mean? It means worldwide, overall. So look at that function and see it as an overall function. Overall, where is the highest point? The highest point here on this function would be C, the maximum turning point. Now, where would be the lowest point? And the lowest point is not a turning point, but it's just an end point. And these 2 points, C and E, are called global because they are the overall, the largest and the smallest value. Whereas this C is called the maximum turning, the global maximum turning point. E is not a turning point, but it is still a global minimum value. And D, A, and B are considered to be local. So we've got a local value endpoint, a local maximum turning point A, and a local minimum turning point B. These terms needed to be revised because maximization or optimal maximization may occur either at a turning point or, for that matter, at an endpoint. And a minimization may also occur at a minimum turning point or a minimum endpoint. Testing optimal solutions is usually done by a sign diagram. So let's just say we have a function fx. We need to now look at fx dash when it is 0. We have 2 places over here where we'll find that the derivative is 0. We need to look at that sign diagram of both of these. So if sign diagram was shown for this upper value, you would note that it would be positive on this side and negative on this side. And if I were to draw a sign diagram for this minimum point over here, I would have a negative and a positive sign across here. So this would be our fx dash. And it means that this indicates a maxima and this here indicates a minima. So that's a first derivative test. What would a second derivative test tell me at these 2 particular points? The second derivative test here, let's look at this particular bit, will tell me the slope of the slope. So let's just say that my slope at that particular point here is m equals to, it's positive 2. Here m equals to 1. Over here, m equals to 0. On this side, m equals to minus 1. And here, m equals to minus 2, because the slope is now decreasing. So if you go from 2, 1, 0, minus 1 to minus 2, what is actually happening is that these numbers are decreasing. So that means that the slope is decreasing of this. So we must say that the slope of the slope is less than 0. Okay, so the slope of f double dash is therefore negative. For a maximum in that case, if I was to show you the two sign diagrams next to each other, one of f dash x and one of dash x, then we would find that one of them would be positive here, negative here, whereas the second derivative of the derivative will be negative. All right, let's have a look at this minimum turning point over here and look at the slope of each one. So as we would go over here, this slope over here would be m is equal to, or say, minus 1. The slope here will be 0. On this side, our slope is going to be positive, and it'll continue being positive higher. So our slope is now increasing of the derivative. And if I do the same and show you the slopes next to each other of the minimum turning point, then you'll notice that at that point, this will be negative, positive, and this whole thing, the double derivative will be positive, means it's actually increasing. And in conclusion, you'll find that these are the sign diagrams for a maximum value, and these are the sign diagrams for a minimum value turning point. In the next video, I'll show you a step-by-step method of solving problems for optimization.